All right, so we're going to do a word problem where we get to apply our elimination method that we've been working on. A florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? All right, so how are we going to start this out? Anybody remember? We're going to define our variables. Variables come from, or the way that we define them comes from the question they're asking. How many, so number of, each type of bouquet can the florist make? So the florist is making regular bouquets and mini bouquets. So let's let X equal the number of regular bouquets. Oh, that's really sloppy. And Y equal the number of mini bouquets. Okay, so from there, to write an equation, sometimes it gets a little tricky to see, well, how do I put these numbers together in an equation? It can be helpful to look for totals. Do you have numbers that are totals of things? Over in the picture, they told us like what each regular bouquet is made of, 5 roses, 11 peonies. Each mini bouquet is made of 3 roses and 5 peonies. We're trying to figure out how many of each type of bouquet we can make. But then in the problem, it says the florist has 118 roses and 226 peonies. So those are the total numbers. We're going to write one equation for the roses and one equation for the peonies. So let's write an equation for the roses. The regular bouquets take 5 roses. So we're going to have 5 roses times every regular bouquet that we make. In addition to that, we're going to use 3 roses in every mini bouquet. So 3 roses times our number of mini bouquets. And that's going to equal our total number of roses, which is 118. We're going to follow that same thinking and write an equation for the peonies. Let's see, a regular bouquet uses 11 peonies, so 11 peonies times our number of regular bouquets, plus we use 5 peonies in each mini bouquet, so 5 times Y are mini bouquets, and that's going to equal our 226 total bouquets, peonies. All right, so here's our system. It looks, X's are lined up, Y's are lined up, equal sign is lined up. So great. We can do elimination. Do any variables eliminate right now? Do we have the opposite coefficients? 5x and 11x? Nope. 3y, 5y? Nope. All right, so we're going to use multiplication to create equivalent systems that we can solve. So would it be easier to get the x's multiplied up to the same number? So think of what can 5 and 11 both multiply into? And the smallest number I can think of is 55. Or how about 3 and 5? Can we multiply the coefficients of the y's, the 3 and the 5, up to the same number? And we can get those up to 15. So I'm going to choose to eliminate the y's first. You might not have a lot of space, so write small or off on the side or whatever you need to do. I think I'm going to run out of room, but let's see what we can fit in here. So we're going to multiply the top equation by, I'm going to choose a -5. That's going to get me a -15y. So I'm going to rewrite our new equation, multiplying everything by -5. We have -25x minus 15y equals -590. So all I did was I took this -5 and I multiplied it to every term in that equation. The bottom equation, now because this is a -15y, we want this to be a positive 15y. So all we need to do here is multiply everything by a positive 3. So 3 times 11x is 33x. 3 times 5y is positive 15y. And 3 times 226 is 678. Now we can go ahead and add our equations together. Negative 25x plus 33x is 88. Nope, it's 8x. Negative 15y plus 15y cancels, so carry down your equal sign. And negative 590 plus 678 is 88. All right, let's divide both sides by 8 to solve for x. X is equal to 11. And remember, x represented the number of regular bouquets, so the florist can make 11 regular bouquets. We want to figure out how many mini bouquets the florist can make as well. So let's go back up to our equations. Which one looks easier? I mean, I guess all the numbers in the first equation are smaller, so I might choose to plug in the 11 for that x right there. So I'm going to do 5 times 11 plus 3y equals 118. 5 times 11 is 55. Let's subtract 55 from both sides. So 3y equals 63. Divide both sides by 3, and we get y is equal to 21. So let's answer the question or let's provide our answer in the context of the question. The florist can buy, let's see, 11 regular and 21 mini bouquets. All right, well, that wasn't too bad. Well, looks like we got another one to do though. Before the florist has a chance to finish the bouquets, a large order is placed. After the order, only 85 roses and 163 peonies remain. How many regular bouquets and mini bouquets can the florist make now? So the bouquets still require the same amount of roses and peonies. It's just the total number that we have to use of each type of flower will change. So I'm going to rewrite the equation. 5x plus 3y, but instead of equaling 118, now there are 85 roses. And then we have our second equation for the peonies, 11x plus 5y, and we have 163 peonies. All right, so we can just follow our same process. Let's eliminate those y's again. We can do that by multiplying the top equation by a -5, the bottom equation by a +3. When we multiply the top equation by a -5, we get -25x minus 15y. So all this will be the same. It's just that number on the end is going to turn into a -425. When we multiply 3 through this second equation, we're going to get the 33x plus 15y, but now it's going to equal 489. We can add our equations together. We have 8x, because -25x plus 33x is 8x. Our y is eliminated, so 8x is equal to -425 plus 489 is 64. Divide both sides by 8, and you get x equals 8. So the florist can make 8 regular and how many mini bouquets? Well, let's take that 8, plug it back into either this x or this x. I'll probably just go with that top equation again. 5 times 8 plus 3y equals 85. 5 times 8 is 40. Now to solve for y, we'll subtract 40 from both sides. So 3y equals 45. Divide both sides by 3, giving us y equals 15. So the florist can make 8 regular and 15 mini bouquets.